So start from easy one or just start from medium level?
From medium hard.
Okay, let's start.
Yeah.
So we have a tree, a binary tree, and we want to find node sums which their grandparents are even value. So let me explain. Okay, you have binary tree. Let's say 6 3 8, for example. You have okay, great. You have let's say 1 2, here we have 3, yeah, 5, for example, and here we have let's say the right node of 1 is 4, then 9 8, here 1 2.
Okay.
Okay, and here the right node of 5 is say 5. So we need the sum of all nodes, all subnodes, let's say, which their grandparents' value is even. So here 1 2 and 3 5. 5's grandparent is 6. Grandparent is the parent of grandparent. Okay, and their all of these grandparent is 6, and 6 is even. So we need to sum up all these elements. So let's say 5, and the other ones, which let's see, 8 is also even, and it is yes, 1 2 and 5. Yes, 1 2 and 5. We need the sum. So create for yourself your test cases. Your design the method for this one.
Okay. Since in a level there's possible sub values that the grandparent is even and another sub level grandparent is not even, so we can do BFS. Okay. So for each value I will move forward its grandparent, okay, and its parent. Okay, so for 6 there is no grandparent, no parent, right? And for 8 there is no grandparent and there is a parent, which is 6.
Yes, great.
Okay. And for 5 there is a grandparent 6 and a parent of 8.
Great.
Right. So we know here that 5 has a grandparent even, so we have to add it to the sum. Right. So let's say that we have a global variable that will save the total sum. So we can do a traversal with these variables for each node, and to check if the grandparent is even. I will add myself to the sum. Otherwise, I will just continue.
Great.
Okay. So we can do an order traversal, and we can take the sum. How does it sound?
It sounds great. So we can move to the code if you want.
Yeah. So I can assume that I have a tree class or I should implement free class and
Yeah,
things
you
like that.
can you could assume that it already exists,
Yeah.
and
So yeah. So let's assume that we have a global variable that is Traversal. Uh, okay. Okay. So I'll have another function that is this will take the root of the angular down here cursor go through and oh no, we don't want we can call it and we will just yeah the purpose. So here if the node is none, I can return, I can stop, right? Um yeah, so if I don't have a parent, so I will not have a grandparent, right? So I just uh, it's, it's um, yeah, will be the same. So here I'm taking myself as a parent for my child, and I will pass my parent as a grandparent for my child.
okay.
Okay, and now I'll check if I don't have a parent, so I will not have a grandparent, right? So let us kind of do. Uh, uh, and so if my grandparent is even,
Hmm.
I will add myself to the total sum, which will be a global variable.
Hmm.
So yeah, I think this will work. Let me check this. So as we know, we have none none. So then I'll go to the left. Um, yeah, so the left will be the parent will be 6, the parent will be 1. So okay.
Okay, if you want,
Yeah.
you can create some test cases, run it,
Ah, I can
and
run it. Okay.
let me also copy this one and check.
I need the tree node, so can remove. Oops. So to the left will be me, and the left will be 1. Right at 1 and this 4. to the tree, to the right, we have 3, and to the left 2. Oh, that doesn't matter, so 9 and 8, okay, so first time, and now to the right of 8, of 6, we have 8, to the left of 8, we have 3, and to the right, and to the right, 8, 5, to the left we have 9, to the right we have this close the 5, and this close the 8, and this is close. This, maybe here, okay, so we have 3, here, then the left of 6, we have 3, the 3 we have 1, and 4, and 2, then 8, 19, so 5, 5, 10, 15, 16, 19, yeah. I think this is working. Can you hear me?
yes, yes, exactly. Great. Great.
I can't hear you well.
Okay.
Have you said anything?
Could you please tell me about time complexity and memory complexity?
Yeah, so the time complexity is 12n, since we are doing a default DFS traversal, which is post order traversal.
Okay.
This is of n time, and the space will be O of h.
Okay.
Regarding to the recursive calls, and the h is the height of the tree. So if the tree is skewed, this will be O of n.
Yes. So thank you. Let's move to another question.
Yeah, sure.
If you want, we can just clear this one.
Yeah.
Okay, we have some word 1 and we have word 2. We only permitted to add a character, remove the character, or replace.
Yeah, edit distance.
Yeah,
I know this question.
yeah, exactly. So find the minimum change we could do to convert word 1 to word 2.
I already know this question.
Okay, so you want to change question, yeah?
If you can, but
Yeah,
I already know this. This is a dynamic programming. I will use top-down approach
yeah, exactly.
to add or remove or replace. This will be of n multiplied by n, and yeah.
Okay,
So,
okay, let's move to another question then. We have a linked list, a single linked list. So we have node 1, we have node 2, node 3, 4, and node 5, let's say. Yeah. We need to, I think that, yes, exactly. I think that maybe you know this question also, but it's
maybe what?
interesting question. So we should change the positions. So we should move the last node after the first node, so L5, then keep the other node, L2, then move the next last one, so L4, then keep L3. So we are changing, we are moving the last one to the current next. Did you
So
understand the question? Yeah.
like we have 2 pointers, something like this, P1, P2, then we will take P1, then P2, and P1 will go to the right, then we take P2, then P2 will go to the left, something like that, you know.
Yeah.
Forget about the left, but if it's array, so it's something like that, we will take P1, then we'll go to the right, and then we will take P2, which was 4, and we'll go to the left, then they are each other, right?
So yeah,
Okay.
we
So
our node is list node maybe, yeah, and it has value and next.
Yeah, without brev, right? Okay.
Yeah.
So the first solution that I can think about, since we don't have a brev pointer, we can reverse the list, and while we have different nodes, so we can take alternatively, like from the first, then from the second, then from the first, etc. Like that. So if I have something like this list, and the reverse will be L5, L4, L3, L2, like L2, then L1, right? Something like this. Then I'll have P1, P2. So first I'll take the first one, okay, and the P1 will go to P2, to L2. Then I'll take the P2, which is L5, and P2 will go here. Then I'll take a P1, which is P2, okay, and then P1 will go to 3. Then I'll take P4, which is L4, right, and then this will go to here. Here I can see that they are the same, right? Because
yeah,
when they if it's an odd, they will meet, right?
Yes.
I can break and I'll take one of them. So just for the odd. If it was even, I think they will not they reach each other. Let me see. I have Yes. Mhm. So we can see that here P3 will come to P4, and when I go, ah, yeah, P1 will go to P4. Ah, yeah, so they will meet. They will meet. Right.
Okay.
So yeah, why they not meet? I can take adjustment, right?
Mm-hmm. Yeah.
So the time and space is all of n, because we are going only once,
Yeah.
and we are traversing the list. We are reversing the list, saving another list, and then traversing alternative.
So you
Um,
will you will copy the current list, then reverse, then traverse both of them. Yes.
yeah, yeah,
So maybe there is some better way.
yeah. Wait, according to time, we can do better, right? Because we need to traverse all the list at least, right? So the
Yeah.
time will be at least all that. The space maybe,
Yeah.
um, maybe we can do better. Okay.
Let's say you can change the input list, so you can do it in place, and in place input is not uh, is not um, is not calculated as a extra memory.
Yeah, yeah. So let me see. If we can cut the array, the list, sorry, into two halves, okay? So
Mm-hmm.
let me see. If I have this list, so we have finished approach one. Let me see the approach. So if I have this list, if I can cut it into two halves, well, something like this, okay?
Mm-hmm.
Right? So I can take, I have two lists, and I will reverse the second list to this, and then I'll
Mm-hmm.
traverse alternatively as the first approach here after reversing the list, right? Because I don't need to reverse after the half of the list. So if it's
Exactly.
even, this will work perfectly. Let me see about odd. So if I have LL5, okay. So I need to take. So I need to take two of those and reverse it. L4. I take L1, L5, L2, L4, then L3. Yeah. So the second algorithm is to take the first half of the list and to save the second half,
Yeah.
reverse the second half,
Great.
okay, and
Mm-hmm.
iterate alternatively, right?
Great. Great. Actually. Yeah. Right.
And this will be a
So
O of 1.
yeah, exactly. If you want, you can write code, but if you don't, we can move to another question.
I think this will not be challenging because I know the algorithm of finding the middle with the slow and fast pointer, and then the reverse
Mm.
list it is easy. So yeah, I think this will be easy.
Okay.
So if you
Uh,
can move to another question, I'll be happy.
okay. You want a three question or three one or something? Another,
What?
not three, three or not three.
Ah, as you like. If you have dynamic
Okay.
programming or graphs, it will be better because
Okay. Um, Today I faced with good algorithm. It was really challenging for me.
mhm.
Let me ask you, maybe you didn't face with this question. So designing circular queue.
Circle is
Circular
cool.
queue
Yeah.
is circular queue is a data structure which the operations are performed based on first in first out
Mhm.
principle, and the last position is connected back to the first position.
Mhm.
Uh, it's something ring buffer ring. So we have let me copy the exact uh, class maybe. Yeah. So
Yeah.
let's clear. Let's put yeah. We
Yeah.
have enqueue method. It's for adding
At
the
the end.
element at the yeah at the queue.
Yeah. At the end. And
Yes,
DQ removing from the first, right?
yes, exactly.
Mhm.
So the other one front is just returning the element from the front.
Mhm.
Rear is from the rear of the queue. If
Mhm.
front and rear, so if queue is empty, we are returning -1.
Mhm.
So is empty and is full is obvious.
Mhm.
And so for NQ and DQ, we are, as you see, returning the boolean. So if we can insert element to the queue, we are returning true. Otherwise, we are returning false, so we can't insert the queue. And also for the queue, if we can't dequeue from queue, we are returning false. If we can, so true. If you
So
have questions, please ask.
the K is the capacity of that here.
Yeah, K is a capacity and it's a
Hmm.
maximum capacity. Yeah. And for
Okay.
example, we could do, let's say, these operations. Let me copy the test cases, for example, and
Mhm.
the results are here.
Yeah.
So it could be something complicated, but you can just ask.
Um. No, but I think we can use linked list.
Yeah.
We have space. We can add. If not, we can return false immediately. And when we DQ, we will remove from the beginning. So I can, yeah, I can use linked list. And there is another double-ended queue in Python. If you know the double-ended queue, which will be the same.
Please,
But
please, please use uh, array the queue instead linked list.
using the array.
Yeah,
You want to use the array.
I'm saying that
If
array the
it's a
queue
linked
is
list, complicated.
more performant. Okay.
Yeah. So if it's a list, it's very easy, right? Because you can add to the end. You will have tail and head and size and capacity, and you will add to the tail if you have capacity. If you don't have, you will remove from the tail. If you will return false, otherwise the DQ will remove from the head, right?
But
But
you you can continue with linked list. I'm sorry, you can continue with linked list. That's okay for actually
yeah,
for interview. But as
you
you
need
wish,
to do the
let's say
array
as you wish.
with array you need the array.
Mm-hmm.
So we have almost okay. So if we want to implement it with array, so let's say that we have this one, 3, okay? So in Q, we have 0, 1, 2, right? In Q, we'll add to here, in Q, we'll add to here, in Q, we'll add to here, right? Then the pointer will reach to here. So, and the numbers are positive, negative, and integer, or we can assume that it's positive integers.
Let's say they are all positives.
Yeah, so yeah, I can put the -1. So here, if I want to enqueue and I can see that there is no -1 here, so I will return false because I don't, I can't add here, right? And when I will DQ, I will DQ the 1. I will add -1 here, and I will remove the pointer of the tail to here, right?
Mhm.
Yeah, so wherever the tail and the head are the same position, it is full, and the empty, hmm, the empty, um, when we are empty, it's also when we are the same. Mhm. So yeah, when we are the same and we are a -1, so I am empty. When we are the same and I'm not -1, so I am full, right? So if I have 1 here, so the tail and the head will be here, right? So let's say that this is a tail, this is a head, right? And
Okay.
it is full, it is the full condition. When I remove this, the tail will be moving, and when I remove this,
Mhm.
the tail will also be moving, and when I remove this, the tail will also be moving, with modulo for sure, and yeah, they are the same, and this is a -1. So yeah. Um. So what do you think? How it sounds?
It sounds great, but think about that. If, for example, if you could add so NQ and DQ all the elements,
If I
what happens?
enqueue,
What happens? So you enqueued a lot of elements, so then you DQ'd all of them. How you
mhm.
understand that queue is empty?
I said when the tail and the head are in the same position and they are pointing on
Mm-hmm.
-1.
Mm-hmm.
Okay, so if they are pointing -1, when I'll add, the head will move. Will be moving, right? The head will point to the next
But
empty.
but tail stays there, yes?
Yeah, the tail will stay, right? Yeah, the tail is
Yeah.
connected to the DQ operation,
Okay. Okay. Great.
right?
So let's you want let's write. Yeah.
Yeah. So okay, let's implement this. Um, so in here. it's full, I can't add, right?
Mm-hmm.
Otherwise, I will add, so go to, so go, add,
Full. We are
but,
returning full.
okay, because I don't want to go over the array size.
So,
Um,
let, let me ask you a question. So, if queue is full, so you are returning false. Yeah. What if
yeah,
we create, so what's the our circular queue's responsibility is that if the queue is full, we can write from the beginning. So it's circular. Circular. We are just adding to the first node. Isn't
yeah, we will add to the first, but if it's full, we can't add. Like here, the NQ4 is returning false, right? But when we dequeue,
okay?
when I dequeue, I'll remove the one. This will become -1. The tail will move,
Okay.
and then I will add,
Mm-hmm.
right?
Okay. Okay. Right.
So it's according to the example here, NQ4 will not be. Yeah, and dequeue. So I will put false, right? Otherwise, we can return. Uh, and, right. If it's empty, I can't remove anything. Then
Okay.
I will put the value -1. I will add to the tail one with offset. So the
Mm-hmm.
front, uh, let me implement this intent. So if it's empty, right,
Mm-hmm.
right. So if they are the same position, okay. Now we can say that. If they are the same position and they have -1, so they are empty. Right. And if they are the same position and doesn't have -1, so that it is a full situation, right? Um,
Mm-hmm.
yeah. So now the front and rear. So if I don't have values at each one of them, what I can do? Oh, I should return -1. Yeah. Can I return -1?
Yeah.
Like I think. Yeah.
Yes.
Oh. So the Q. So I'll return whatever I have in here. And the rear, I return in L-1. Right, so if I have here in the tail at 0, so the tail 0 minus 1 will be minus 1, so we return true. Right, if it's was a 1, we return 0. Um, yeah, I think, what do you think?
Uh, it seems okay. Let me check in lead code. Let's see this one. Right in the lead code. Okay. Uh, so in the line 15, let me. There is some heat here. Gives an error which list assignment index out of range. Here.
Maybe this, maybe something like this.
The error is one line before that line. So it.
Yeah, I know, but the head will be moving here, right?
Yeah.
So if the k is 0, we can't add, right? Maybe this is another case, but I'm wondering if this is the error. Because the modulo and the pass maybe making thing here. So, um, yeah, yeah. So can check now.
Yeah. Okay. It seems okay. So let me try all these cases. Okay, you have an error. So let me send to you. So let's say you have this input. I think you will understand this one. So your output is this one, but the expected answer is that one. Using
Mm. The tail, the real function. Um, yeah, so let's say we have this one. So I added one, so here's the 10, and here is the head, right? Um, yeah, just after we full, this will be moving, right? Um, now, I think two, then three, okay. Oh, then up this one. Oh, okay, so why it's minus one? So it's supposed to be a tail, you know. Then we'll check again. Yeah, I have fixed the bug with the real object.
You have
I have fixed the bug. It was here. Got certain here. So tail minus one.
hmm, shift Q minus one. So you mean the
Yeah,
one element
it,
before?
yeah, because it was circular, so I thought it was one element forward. Yeah, I am pointing to the last element at each time. So, what do you think?
Maybe. So problem. What's the problem? What problem? So we have circular Q with size 6. Yeah.
Mm-hmm.
When we are in Q6,
Yeah,
yeah, in Q6, it should it returns true. So it means we are successfully adding. Yeah.
yeah,
And when we are want to get rear, so with we added only one element, so rear should be the current one.
fixed. Yeah, so I have fixed the bug. It was center tail minus one, so I removed the minus one. Now it should work.
Oh,
Yeah, I told you I
I
have fixed the
thought
bug.
that. I'm sorry. I'm sorry. I thought that you didn't change. Okay. But now our first test case is failing.
um, yeah, so here's one.
The other one works fine. If you want, I can send you the actual and expected. So
Mm,
in place
yeah,
of in place of
I can see when
uh,
it's full, when it's full,
mhm.
uh, I need to turn the one element before. When it's not full, I can turn regular time. Right, so here I'll take you.
So, do you, after
Okay.
problem is
So I
how
can check the question, but yeah, what do you think overall?
overall it's great. So actually, I I took a lot of time to figure out this problem actually, but you are near to the success, so it's great. How are you preparing for interview? Only lead code?
I have practiced an interview bet and doing a lot of VRAM, and now it's the first time of interviewing.io, and I
Mhm.
used the cracking the code interview book and the lead code.
So you good, you did great. You did great. Actually, my first my first interview in interviewing IO, I only did first one, and second one was the medium one, which wasn't a hard question, but I don't know why I can't solve the problem. Maybe I stuck with something, and actually, when you are stuck in something, you stuck, so you can't break that one. So
Yeah,
the good one is to think about all edge case and write once rather than write then think, because after writing, changing and fixing the issue is hard.
yeah. Takes more time.
Yeah. So I can send you the this question link if you want to try
Hmm.
then. Okay, I'm writing here.
Yeah.
Uh, So
Yeah. Thank you.
yeah, yeah, just 3 minutes. Thank you very much. It was great. It was interesting. So goodbye. Hope
Thank you.
you'll dream job.
Good luck with your journey. Bye bye.
Thank you. Bye bye.